Scientists believe that dark matter makes up about 85% of the matter in the universe. It is called dark because it doesn't interact with light or other forms of electromagnetic radiation, and it cannot be detected using any detectors or sensors currently in use. Scientists infer its existence because of its gravitational influence on ordinary matter. When astronomers Vera, Rubin, and Kent Ford made Doppler observations of the orbital speeds in spiral galaxies, they discovered that the stars far from the centers of galaxies in the sparsely populated outer regions move just as fast as those closer to the center. They were surprised by this observation because the visible mass of a galaxy does not have enough gravity to keep those outer stars in orbit. They concluded that there must be unseen matter in the outer regions of galaxies. Vera Rubin concluded that, quote, in a spiral galaxy, the ratio of dark to light matter is about a factor of 10.
Unquote.
Nola Taylor-Tillman of Space.com says,
quote,
a vast majority of the astronomical community today accepts that dark matter exists.
Unquote.
She also acknowledges that it might not exist.
Quote,
despite all the evidence pointing toward the existence of dark matter, there is also the possibility that no such thing exists after all, and that the laws of gravity describing the motion of objects within the solar system require revision.
Unquote.
Dark matter has led to a lopsided disagreement among scientists. Most believe that the universe is filled with a mysterious substance that can't currently be observed, while others think that our current understanding of how gravity works is incorrect. Scientists who reject the dark matter hypothesis propose alternative explanations. They argue that our current understanding of gravity may not be complete because galaxies don't follow the laws of physics as we currently understand them. Critics of the dark matter hypothesis point out that stars in faraway galaxies move differently than expected if the dark matter model were accurate. Modified Newtonian Dynamics, MOND, is one alternative to dark matter. This hypothesis proposes changing Newton's law of gravity to explain how galaxies move. Supporters of MOND argue that we don't need dark matter to explain how galaxies move. Instead, we need to change how we think about gravity. Pavel Kroupa, a professor of astrophysics at the University of Bonn in Germany, argues that dark matter doesn't exist because if it did, lighter galaxies orbiting heavier ones would be slowed down by dark matter particles. However, he claims that no such slowdown can be detected, and that a host of other observational tests support the conclusion that dark matter is non-existent. The implications of this require a revision of Einstein's theory of gravitation. Kroupa is critical of many in the scientific community because, despite numerous searches for evidence of dark matter particles over the last few decades, none has been found. In his article, Dark Matter Doesn't Exist, he lists some theories scientists have proposed to explain what dark matter might be.
Quote,
these scientists claim that dark matter could be extremely lightweight fuzzy particles that extend over thousands of light years, or that it may be made up of particles that are heavier, such as weakly interacting massive particles, WEMPs, or even primordial black holes that form from exotic physical processes during the Big Bang.
Unquote.
Kroupa argues that the theory of dark matter doesn't provide any specific predictions about what the particles might be or how they might be detected. He criticizes scientists for spending large amounts of money searching for dark matter with the goal of winning a Nobel Prize. Kroupa, his students, and other collaborators have studied the motions of galaxies near and far. He argues that none have shown evidence for the existence of dark matter. Kroupa claims,
quote,
the galaxies behave as if they were naked, i.e., as if they did not possess the huge and massive halos of dark matter particles which the theory predicts to be there. Rather than observing the slowdown of galaxies, we observed a speed up as the galaxies fall toward each other.
Unquote.
Some scientists think that Einstein's theory of gravity may not work on a large scale, like the scale of galaxies or galaxy clusters. They suggest it may only be accurate on small scales, like the scale of the solar system. If this is true, dark matter may be an unnecessary explanation for the behavior of galaxies that Vera, Rubin, and Ken Ford observed. Scientists have yet to find hard evidence for the existence of dark matter, but it is widely accepted as the best explanation for the observed behavior of galaxies. Dark matter may be a real substance that scientists will eventually be able to detect with a sensitive enough test. Alternatively, it could be something like Ptolemy's epicycles, an idea that scientists accept because it makes the math work, but which may not actually reflect reality.
Thanks for watching. Check the pinned comment for links, and don't forget to like and subscribe.